Hey folks, Quilly18 here, and welcome to another Unity 3D tutorial where we work on Project Porcupine, our base building game. In the last episode, we created a few very basic classes to hold our data. These are data classes: the tile data, the world data, the object data, and then we created our first controller. So we have an object here called called world controller, and it's got a world controller script on there. And the job of controllers is to link the visuals of our game to the data of our game. Right now, well, that's not really happening. Our world controller just does one thing. If we open that up, there we go. Our world controller on start creates a new instance of the world. Our world script is responsible for spawning a bunch of tiles, and that's it. And our tiles just sort of exist to hold some data, not really do much. So we want to get some visuals going on there. Now, the way that you would often do this in Unity would be to create an empty of some kind, populate it with some stuff like, for example, a sprite renderer, give it a sprite, which I'm going to talk about in a second, and then turn it into some sort of prefab by dragging it into your project down here. We are not going to do that. We are going to create our game object procedurally, which is to say it's going to be created in the script, which is going to be very cool and stops us from polluting our sort of project here with things that we don't really need to have down here. I did go and create a very fancy schmancy floor tile for us. It is sort of a light gray tile with a slightly darker gray border. It's so beautiful and sexy. A couple of things you're going to want to do, most likely in your 2D games, 99% of the time. First of all, normally this comes in compressed. You're going to want to change it probably to something like true color. You can experiment with different things. If you have it compressed, compressed is like a JPEG compression basically. It works great for anything that is like a realistic photo type stuff. It dramatically reduces the size of the image without really leading to any sort of visual weirdness at all, and it's awesome. It doesn't work so good for drawn stuff, and drawn stuff tends to be smaller. We're just going to go with true color for here. It's going to be fine. Filter mode, we're going to change it to point filter. Again, depending on your graphics, bilinear might be fine. Basically, it just helps to deal with how you sort of, if you're not viewing your image at a 1:1 pixel ratio, how does it treat it properly? For drawn stuff like this, we're going to be a lot happier with the points, and so not filtering it. And we turned off the bitmaps as well, just because we're not going to need them for here with our simple graphics. Now, the very important step is this one here, pixels per unit. We want each one of our tile graphics, these floor tiles, to be 1 unit in the game world. So that way, if we have a floor at say 0, 0, and we have another floor to the right of it at coordinates 1, 0, right over here, we want them to be flush to each other, right? And which means we need the graphics to literally be the right size so that each one of these squares visually comes out to exactly 1 unit in Unity coordinates. And the way we do that is by setting the pixels per unit to be the same as the width and height of the image. This is a 32 by 32 image, so we tell it the pixels per unit are 32. Bam, it's going to look great. And we'll see that very soon. So I've got my little graphic in here. So what are we going to do? So basically, first step, our world gets created, which creates all of our tiles. Excellent. Second step, we're going to go and we are going to create a game object for each of our tiles. So they show visually. I mean, I know that that's sort of a redundant sentence, but it gets the point across, right? So that we can see our tiles. We need game objects because game objects are what Unity renders to the screen. So we need to create game objects. So what we're going to do is we're going to have a for loop, right? We're going to loop the world. We're going to go, X from 0 to the world width and so on. Unfortunately, we actually can't currently access the width of the world, can we? The world's width gets stored here and here. Now, when we instantiate the world, I mean, we can pass this stuff, right? We can explicitly tell it what the height and width is, and so we could use that data here, but we're going to want to be able to get this info quite often. I like having this be protected because we don't want, as opposed to public, because we don't necessarily want to one day decide to change the height and width somewhere else in our program. I mean, it's our own program. Hopefully we won't be dumb about it, but hey, we're maybe open sourcing this, going to get some other people working on this. We don't want them to write code that changes the size of the world. That would be crazy. Almost certainly not what we want. So I can make a function here. I can make a public function, right? Public int get width return width. And there's nothing wrong with that. And effectively what we're about to do is exactly what this is, but we're going to use something called an accessor instead. which is a very, very swell way of doing it. And basically, well, we can actually use a shortcut in MonoDevelop to do this for us. We can go refactor, create a getter, and we can tell it where to put it. I'm going to put it right here. I'm going to hit enter. So this is creating a property on our world, which is going to be capital W width, with a getter called return width. And what's interesting about this is now we can access this width property basically like a variable. Instead of calling a function called, say, get width, I can say something like world.width and like just stuff it in something. Int w equals this. It's sort of kind of like a function, but somewhat more convenient to work with. This, you can also do setters, right? This just has a get, but I can also use a set. And if I have it a set, that means I can say something like world width equals 999. Now, again, I don't want to do that with width, but I want to do that with something else. Anyway, here's what we're going to do. We're going to do a for loop, and there's a cool little shortcut in MonoDevelop. If you use it, you can, if you type for, you can hit tab, auto completes it. Not only that, I can now say, so it's got the, by default, it fills it in where I equals 0, I is less than max, but it's got the I selected right now. I can actually hit X. See, replaced all the I's with X, and if I tab over, I can replace the max with something like world.width. And then I'm going to hit enter. I'm going to hit enter again. Then I'm going to hit for, tab, y tab, world.height. Oh, I don't have an accessor for it, so it'll give me an error for now. Enter. World. Right click on height, refactor, create getter, enter. Bam. So there we go. Good. Now I can loop through all of those. Excellent. Okay, so now we're going to create those game objects for every one of these tiles. How do you create a game object in code? It's really easy. Game object tile underscore geo, I guess that's fine. Tile game object is equal to new game object. Boom, done. That's it. Now we have a game object in our game world. And let's be a little fancy. Let's give it a name. Game object dot name is equal to tile underscore plus x underscore plus y. Sure. Let's run it and see what happens. Boom. Run. Shabam. Suddenly, we have 10,000 game objects added to our game world. This, as it turns out, is not as rough as you might imagine. You certainly don't want to be creating that many game objects constantly, but Unity can handle a fair number of game objects that are simple game objects. These are game objects without any components, without any scripts attached to them. It's not too bad. Again, later on we might optimize things so that we only create visual tiles for tiles that are within the camera view, but yeah, let's not worry about it until we get there. We'll wait, okay? So we create a game object, that's great. Now, it's just an empty game object right now. We obviously want visuals on there, and the way we do visuals for 2D objects is with a sprite renderer component. We can add that in here. We can say tile.gameObject, oops, tile underscore gameObject dot add component, and you can use these like cool little templating system to say, hey, add a sprite renderer. There we go. So now it's added a sprite renderer component to my tile game object. And this actually returns a copy of the sprite renderer. So I can say, oh, okay, tile sprite renderer is equal to that. Well, that's very handy, because then I can set a sprite. Like that. We can tell it what the sprite should be. Now, right now, world is just creating a world of, well, empty sprites. They've got no floors or anything like that. So really, I mean, everything in the world right now will just be empty space with no visuals. So we don't actually have to assign the sprite right now. If we leave it with a null sprite, this sprite renderer literally won't do anything. Potentially we can squeeze out a bit more performance if we did something like enabled equals false. But I think it'll instantly return if the sprite field is null. Now, it'd be nice to shake this up a bit, wouldn't it? What if we added a function, just for testing, in our world, right? Let's add a public void randomize tiles in our world over here. And we're just gonna loop through the tiles. We're gonna loop through our entire tiles, and we're just gonna randomly say something like if random.range 0.2. Because these are integers, this will either return a 0 or a 1, because it returns 1 less than the second number. If it's an integer, if it's a float, it's different, but these are integers. So this will return 0 or 1. So if it returns, say, 0, then let's set the tile type to empty, right? So tiles at xy dot type. Type. Okay, so there's get type. This is different. This is a system type, which is not what we're doing for. We want the tile type, but it's protected. Tile type is protected. Well, how do we write to it? Again, I could make this public, which would certainly be very easy. I could create a function here that would set tile type to something, but let's go ahead and let's use the property. So create getter just creates a get. Create property creates both the get and the set, which is very handy. So now I can say get tile.type, very nice, is equal to tiletype.empty. This is a bit redundant, of course, because empty is already default, but what the hell, let's do it. And there's a reason I'm doing this. The reason I'm actually adding this in is that way we can call randomized tiles over and over and over again if we want to mix things up. So otherwise, we're just going to set it to be a floor. Okay? If we randomize a 0, it's empty. If it's not a 0, we set it to be a floor. So in our world controller, after we create the world, let's randomize all our tiles. Half our tiles will be empty, half of them will be floor. Great. So here at this point, I guess we could check to see what the type of the tile is. If tile, which is... Oh, we don't actually get it yet. So at this point, we should do something like tile data. There we go. So we got tile game object and the tile data, which is the world.get tile at xy. So we got tile data. So if tile underscore data dot type is equal to floor, then we do want to set a sprite, right? Our tile.sprite data.sprite, we want to assign it some sort of sprite. What is it going to be? Where are we going to grab this from? Later on, we'll probably have all kinds of fancy schmancy ways of getting types that based on tile type and whatever. For now, let's just use a shortcut, because really, right now, there's only going to be 2 tile types. Either it's going to be empty space or there's going to be a floor there. And everything else really right now, walls, doors, those are all going to be objects that sit on top of a floor. They're not going to change the tile type. So for now, let's go ahead and do public game object, or actually not game object even, public sprite floor sprite, like this. Okay. If I tab out and we look at the world controller, now it has that spot in the inspector for the sprite, and I'm going to drag my beautiful floor graphic into that spot right over there. Okay. So again, back down here is if the tile data's type is equal to a floor, then set the sprite to floor sprite. Okay, roughly half the tiles in our world will be a floor. It'll be randomized, but roughly half the tiles in our world will be a floor. There's something that I'm missing here, but I'm going to go ahead and hit play anyway, and the game will actually run relatively slowly. So I'm going to hit play, and there we go. Now, we've got it. Have you realized one of the problems? All of our tiles are existing one on top of one another. They're all clustered in the same spot. I never changed the position. So that's one thing. But the other thing to note is right over here, it might be a little hard to see unless you're looking at it full screen, we're only hitting about 30 frames per second, and that's on my real beast of a computer. 30 frames per second is very poor, unless you're on a console, obviously. But all we're doing is rendering some simple 2D tiles with no animation. Why is it going so slow? The reason it's going so slow is because we've got 10,000 game objects, and they're all on screen in exactly the same place. So at this point, you might be thinking, okay, you can't create 10,000 game objects. And again, long term, that may very well be the case. But let's see what happens when we remember to do something very, very important here. After we create our game object over here, and we rename it, let's change its position. Let's change its position to be the proper position for our tile. Tile.x. Tile.x is, or actually it's supposed to be tile data. Where's our tile data? Right over here. Make sure we grab the tile data first. So we're going to set tile underscore data.x. We can't. There is no x. Why is that? Again, x and y are private. Now, so we want to be able to access it. Again, we could make a public or some sort of function. Let's use a getter. We don't want a setter. We never want to change the x and y coordinates of a tile once it's set. That makes no sense. That's not how our tile system works. So what we will go ahead and add a getter for x and a getter for y. We might restructure this later so that all of our variables are clustered together and then all our accessors come after, our properties come after, but for now this is going to be fine. So now we should be able to go tiledata.x, excellent, tiledata.y, and for the z, 0 is going to be perfectly fine. So now all our tiles will be positioned correctly. Let's go ahead and hit play again and see what happens. Aha! Now, first of all, the world looks right. I mean, obviously, again, it's totally randomized, so it's going to be all screwed up. But not only that, you can see the frame rates are sitting around 80 or 90. This is actually because, by default, Unity will run with VSync turned on. So it looks like, oh, we've tripled our frame rate. That's really good. No, we didn't just triple it, my friend. If you go into Edit, and then Project Settings, and then Quality, you've got all your quality levels, and one of them, you can click on them, and this is the level that the editor is running at. If I go down to Fantastic here, and in Fantastic down at the bottom, which says VSync count, if I set it to don't sync, VSync will now be turned off. Now, instead of, so every X number of times per second, your screen redraws, like your actual physical hardware. And by having VSync turned on, it means your games and stuff will only run as fast as the screen can update, because there's no point in updating the graphics any faster than that. That's for the actual screen, like drawing stuff. Your update routines, your update functions on your scripts will still run basically as fast as the system lets them. I might be lying to you about that. Anyway, we turn off VSync for a second. Let's hit play and see what our frame rate is. Our frame rate is now sitting around 2,000 frames per second. That's a hell of a lot better than 30 frames per second. A hell of a lot. And no matter, hashtag PC Remaster Race we want to be, there's no reason for the game to ever run at 2,000 frames per second. But we can be satisfied that our performance is not terrible right now. Even though we still have 10,000 game objects, Unity at least knows not to render anything that is off screen. It still exists in memory, and if we had scripts on these game objects, they would still be running, and that sort of thing. And maybe later on, having 10,000 game objects will still not be performant. But for now, we're laughing. And the fact is that most of our game objects won't need any scripts unless they're like an animated component. Most of our game objects literally will just sit there, and instead it's going to be all the world, the tile, and then the loose object and install objects scripts that will be running, and they are not attached to game objects. They will run very fast, very optimally, and we have the option of multi-threading things as well. Although multi-threading is a whole big giant black hole, so let's not go there. Okay, so this is great. This is excellent. Can you guys see a problem? I can see a problem. So we randomize the tiles here at world creation, right? Create the world, randomize the tiles. Then we generate a bunch of visuals based on the current tiles type. What happens when a tile changes later on? What if we build a new floor or destroy a floor? I don't know. Let's run a quick little test here. Let's create a float randomize tile timer. 2 seconds. And in our update, we're going to go randomize tile timer, and we're going to decrease it by delta time. And then if it's below 0, what we're going to do is we're going to call world.randomize tiles again, and then we'll reset the timer to 2 seconds. Every 2 seconds, we're going to re-randomize what the tiles are. That's fine. That's fair. Okay. What happens if we hit play? So the world renders, and then we wait 2 seconds, and nothing happens. Well, that's not true. This is running, assuming I didn't make an error in my code here. This should all be running. Every 2 seconds, the tiles are being randomized. Tiles that were empty might now be floors, and tiles that were floors might now be empty. But we're not updating the visuals. So what do we do? Well, we got a couple of possibilities. Every single frame in here, we could loop through every single tile in the system, all 10,000 tiles, and check to see if their type has changed, and then update the graphics accordingly. It might be okay. At this point, we're really starting, like every single frame, we're going to loop through 10,000 or maybe more tiles for something that's going to change very rarely. I mean, honestly, even when you're like building your space station, you're going to change. It's like, oh, in this particular minute, I changed 10 tiles. Well, that's nothing. That's a lot of frames where nothing is happening. So there's two ways of getting this information from our tile data. One way is called polling, which is what we would sort of classically do, which is what I just described. It's the equivalent, you know, when there's an election going on, people are calling your house to find out what party you're going to vote for. Well, that's polling. So we can poll the world or the tiles and say, hey, did you change your type? Hey, did you change your type? Hey, did you change your type? Or we can use a callback system, which should be pretty familiar to you if you've ever, say, programmed in Unity. For example, have you ever done something like on collision enter? Right? You can write this function on an object that has a rigid body and a collision box, and this function will be called whenever your object collides with something else. Well, that's pretty handy. You know what would be awfully nice? Is if we could have something like on tile changed type. Or maybe, let's do on tile type changed. I think that might be better. Yeah, on tile type changed. Wouldn't it be really nice if that could get called anytime that happened? That's very, very, very easy for us to do. So, here's the problem. Well, I'm trying to figure out like how to explain this because we're gonna need a couple of more advanced techniques, and I'm trying to like sort out in my brain how to approach it so that it gets built up in the right order. What does on tile type change need to be? Let's tell you what. Let's write this function. So okay, we need to know. Well, we need to know what tile data we're talking about, right? And then I guess we need to know what tile visual to change. We need some sort of like we need the game object with the tile game object, and then we need to be able to do something like tile dot, actually not like this. We need more something like something more like this. If tile underscore data dot type is equal to floor, then the tile game object dot get component dot sprite renderer dot sprite is equal to this, and then I guess else, if it's not equal to floor, we just set it to null. Right? Because it should be empty. If it's not a floor, it should be empty. I guess if we really want to be thorough, what if we did something like else if, and then copy all this. You know, if it's equal to empty, then we set it to null. And then we can have an else here that just goes debug.log error. Something like unrecognized tile type for now. So if you've set it to anything other than floor and empty, which right now doesn't exist as a tile type, but you know at some point it might, and then maybe we've forgotten to update this function, we'll just throw up some sort of error message and then do nothing, basically. Good. All right, groovy. This is what we need. We need the tile data and we need the game object, and then we just need to update the game object's sprite renderer based on what the tile data's type is. All right, clear as mud, hopefully. Hopefully a little clearer than that. Excellent. So we've got that function. Good. How does this get called? Right? Because I'm actually going to do a little bit of a switch here. Let's not randomize the tiles right away. Let's create the world. So create a world with empty tiles. Let's just create the world empty. Then let's just create the tile game objects as is. And let's not set the sprite renderer. We do have to add a sprite renderer, but we're never going to change it. We don't set the sprite. We just add the sprite renderer and leave it null, because right now all the tiles are empty. Right? Add a sprite renderer, but don't bother setting a sprite because all the tiles are empty right now. Right? We're counting on the fact that then we're going to say world.randomize tiles. This is going to run. It's going to change the type of all the tiles, and then, or well, roughly half the tiles, I guess. It's going to change the tile types, and then this will get called, at which point we'll update the graphics. So if we run it right now, I think we get no error, but all of our tiles are just blank. They're in the right position. All the game objects, right? They're in the right position. They have their sprite renderer, but their sprite never gets updated. Our randomizer is getting executed every 2 seconds. Actually, we could put in a little script here. Debug.log, and we just say this. Randomize tiles. So we run this, And we should see. So randomized tiles got called, and then 2 seconds later, and then 2 seconds later again. Excellent. But right now, on tile type change is not being called. So how do we get that done? Well, in tile, we have our accessor, our property getter and setter over here, right? So the only way to change the tile type from outside of the class itself, because inside the class we can set type directly. But outside of the class, the only way to change it is to do this, which calls this and sets it. So after this gets set, call the callback and, let things know we've changed. So how do we do that? How do we call this function from here? That is going to require that we mess around a little bit with a kind of variable that can hold a reference to a function. It's very cool, very awesome, and actually ends up making your code a lot simpler and cleaner, but it's something that you haven't experienced yet. So we're going to go ahead and put a cut in here, but next time we're going to be talking about delegates and actions and things like that. See you next time, folks. Oh, and lambdas. Very exciting. Lambdas are my favorite. Bye-bye. Hey, thanks for watching, and thank you everyone who supports this channel via Patreon funding. You make it so that I'm able to dedicate more time towards creating more content for this channel and to continue our game programming tutorials. If you want to help support the channel, please go over to patreon.com/Quill18creates and support us today. Thank you very much.